All right, these notes are for 1.3 geometric sequences. And so the first thing we're going to do is we are going to write down this warm-up stuff. So take a moment, write it down, pause the video. Okay, so we're going to simplify using an exponent. So if we have 2 times 2 times 2 times 2 times 2, this is the same as having 2 to the 5th. Okay, so we multiplied 2 5 times. To shorten that, we write it as 2 times 5. Then we have 15 times 15 times 15. This is the same as 15 to the 3rd power because we multiplied 15 3 times. If we're going to expand and we have 10 to the 4th, this is telling me I'm going to multiply 10 to itself 4 times. 5 to the 6th, this is telling me I'm going to multiply 5 to itself 6 times. Okay? So this is important to note because we're talking about geometric sequences. And a geometric sequence is a pattern of numbers where you multiply by the same number. Okay, so last time was arithmetic where you add and subtract the same number. Geometric is where you multiply the same number. Next up is a common ratio. This is the number you multiply by in a geometric sequence. So this is the actual number that you're multiplying down your table. So let's look at an example here. Let's say at 0 minutes we have 2 dots. At 1 minute we have 6 dots. At 2 minutes we have 18 dots. I can count fast. So make sure you write this out too. All right, anything that's here, you got to write. So we're going to write our expanded out table here with n, f of n, extended and simplified. Okay, so at 0 minutes we had 2 dots. At 1 minute we had 6 dots. At 2 minutes we had 18 dots. And at 3 minutes we're going to have 54 dots because as we go down our table here, we are multiplying by 3. Right? 2 times 3 gives us 6. 6 times 3 gives us 18. 18 times 3 gives us 54. If you didn't know that off the top of your head, that's okay. But hopefully you knew 2 times 3 and 6 times 3. So let's extend this out just like we did our arithmetic. Okay? So we start with a 2, we bring over a 2. Then we have 2 times 3 because we did 2 times 3 to get 6. Then we did 2 times 3 times 3 to get to 18. Then we did 2 times 3 times 3 times 3. I think that was enough 3s to get to 54. So now we're going to simplify this, okay? And I always like to start at the bottom. So I multiplied 3 3's together, so I'm going to have 2 times 3 to the 3rd. In the next one, we multiplied 2 3's. So I'm going to write this as 2 times 3 to the 2nd. And you can use the dot multiplication or parentheses. Either is fine. I like the dot personally. And then the last two, we have 2 times 3 to the 1 because we multiplied 3 once. And then we have 2 times 3 to the 0 because we didn't multiply by any 3's. Now we're going to write the recursive for this guy. So again, a recursive always starts with f of n equals f of n minus 1. Our common difference this time is times 3. And then we have to write the start of our table, which is f of 0 equals 2. Miss Rawolf, where did you get the 0 and the 2? I got it from the start of my table right here, 0 and 2. Now you got to be careful because with geometric, you can write your recursive a little bit different. You can write it as f of n equals 3 times f of n. So you can flip-flop the location of where you multiply. So here we multiplied in the back, but here we multiplied in the front. These two mean the same thing. And again, you'd always have to give your start value. Then the explicit, remember for an explicit, we're always going to look at our simplified section here. So let's pick a different color. Let's pick blue here. So it's always 2 times 3. So that means in my explicit, I'm going to have 2 times 3. However, my exponents are changing. So that's going to be my n. So let's look at this. My explicit starts with f of n equals, and then we have 2 times 3, matching this guy here. And then we have an exponent n, because n is what's changing. That exponent is what's changing as we go down our table. Let's look at another example that is not with pictures. So we have 160, 80, 140, right? So these numbers are getting cut in halves, right? 160 is divided by 2 gives us 80. 80 divided by 2 gives us 40. 40 divided by 2 is going to give us 20. However, in geometric, you cannot do divide by 2. We have to write this as a multiplication because geometric is all about multiplication. So what happens is, instead of divide by 2, we're going to change this 2 times 1 over 2. We're going to change it into a fraction. We're going to change and flip it. Because, Miss Rawolf, how does this happen? Because this fraction bar that everybody seems to like or dislike really means divide. So we can write division as multiplication because of this super secret trick of this fraction bar. So this means that going down our table, we are multiplying by 1/2, aka secret, quote unquote, we're dividing, but we have to write it as multiplication for geometric. So we are multiplying by 1/2. We are multiplying by 1/2. So when I look at my extended, I bring that 160 over, because I always just copy this number over to here. And then as I go down my table, I have 160 times 1/2. That's how I get 80. I have 160 times 1/2 times 1/2. That's how I get 140. I have 160 times 1/2 times 1/2 times 1/2 to get 20. So now I'm going to simplify this. And this time I multiplied by 1/2 3 times, so I have a 3 exponent. I multiplied, I'll get rid of all this. I multiplied 1/2 twice here, so I have a 2 in my exponent. I multiplied 1/2 once here, so I have a 1 in my exponent. I multiplied by 1/2 not at all in the top row, so I have a 0 exponent. And you got to be careful, because with fractions, we really want to make sure we put that parentheses sign around here, because if you don't, then it won't calculate correctly in your calculator if you use it. If you struggle with finding the common ratio, which in this case was times 1/2, what you can do is you can take the next number and divide it with a fraction bar with your previous number to get that common ratio. So, for example, if we have the next number here is 80, and we divide it by its previous number, 160. Or if you want to do 40 and divide it by its previous number, 80. Or if you want to do 20 and divide it by its previous number, 40. All of those, no matter what you do in your calculator, is going to give you 1/2. Or sometimes it's going to write it as a decimal. The decimal would be 1.5. But these are the same thing. Okay? All right, that's all I have